Well, today we're going to be doing number systems, and I'm going to start from the beginning. Okay. This topic is actually very important for when you do nature of roots later on. I think you're going to do it in grade 11, if I'm not mistaken. So make sure that you understand this topic so that you can find nature of roots easy. So I'm going to start from the beginning and I will define each of the number sets. So the first set of numbers we have is called natural numbers. It's called natural numbers. Please note that the n is a scientific notation for natural numbers. So if you write that n, it's simply in mathematics or the languages in mathematics language that n represents a set of natural numbers. So by writing n, we will know without you having to write natural numbers two words. You can just write that n, and we call it a scientific notation, which signifies natural numbers. It simply tells you that now you're dealing with natural numbers. Now, what are natural numbers? Natural numbers are called natural numbers because it is natural to count from 1 up to a certain number close to infinity. Okay, I gave you examples there. That is 1, 2, 3, 4, 5, 6, so on and so forth. So no decimals, no negative numbers. They're also called natural numbers because it is natural to count from 1, as I've said, and we normally refer to them as counting numbers. Then we've got whole numbers. Please note that whole numbers is simply what it is. You just add a whole to your natural numbers. A whole in math is 0. Okay, so you just add 0 to your natural numbers and you will get a set of whole numbers. You will realize that the scientific notation for whole numbers is similar to natural numbers, except that right at the bottom, we include 0 to signify that you're talking about whole numbers. Now, whole numbers, as I've said, are simply natural numbers plus 0. You just add 0 to natural numbers, and then you will get whole numbers. Another set of numbers will be your integers, which we normally use Z as your as a scientific notation for integers. Integers are whole numbers plus the negative natural numbers. So you'll realize that I took my natural numbers and I just put negative and plus your whole numbers. The combination of the two will just give you integers. Integers are just negative natural numbers plus whole numbers. I just need to specify that. Please note that when it comes to negative numbers, a number that is close to 0 is the biggest. When it comes to positive numbers, a number that is furthest from 0 is the biggest. I hope you got that. Meaning that -1 is bigger than -100 when you deal with negative numbers. And obviously 10 will be bigger than 1 when you deal with positive numbers. All right. And then we've got rational numbers. Rational numbers, the scientific notation for that is just Q. These are numbers that can be expressed as a fraction. This includes finite and recurring decimals. All right. What is a fraction? A fraction has a numerator and a denominator, where the denominator can be any number except for 0. Thou shalt not divide by 0. That is the biggest commandment in maths. Thou shalt not divide by 0. All right. The denominators I've set may not be equal to 0. Later on, we'll deal with fractions just to define what fractions are. I think yes, we will deal with them later on. And we will go deep into the definitions of fractions. However, please note that a numerator can be any integer, but the denominator may not be equal to 0. Okay. However, a numerator can be anything. It can be 0, but your denominator cannot be equal to 0. The principle behind that is that you cannot divide nothing. Okay, if you've got nothing, then you cannot divide nothing. But if you have something, you can still decide not to divide it. All right. Now, understand that. So basically, if I have something and I cannot divide it, obviously I'm dividing it amongst 0 people. So the answer will just be 0. But if you've got nothing, then there's nothing to divide. So that number doesn't exist at all. Okay. Here are examples of of rational numbers will be 3/2, square root of 9. Please note that square root of 9 is just 3. Cube root of 27 is just 3. Negative square root of 144 is just -12. 0.7 recurring. As I've said, rational numbers includes recurring decimals. 0.7 with that dot on top, it simply can be written as 0.77777777777. All right. And then we've got a new set that was born from rational numbers. We call it irrational numbers, right? Irrational numbers, you realize that the scientific notation is the one that is given to you now. These are numbers that we cannot express as a fraction. These are numbers that cannot express as a fraction, meaning that they will not have a numerator and a denominator. Now, non-recurring decimals are classified under this set of numbers. Non-recurring decimals. Note that when we say decimal is recurring, we're simply saying the decimal is repeating itself. So non-repeating decimals are classified under irrational numbers. And examples of irrational numbers will be the square root of 3, pi. Pi is simply 3.14, blah, 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 blah. It has a lot of decimals. I know that a lot of people might say that, but pi can be expressed as a fraction. No, you may not express pi as a fraction. Pi may not be expressed as a fraction. I know some of you think that pi is 22/7. That is incorrect. Pi cannot be expressed as a fraction. It's just a long number. Even your calculators are just abbreviating pi, reducing it to I think 10 decimals, which is also incorrect. It goes over a long list of decimals, all right? And then we've got 0.1, 2, 3, 4, 5, 6, 7, 8, 9. You'll realize that the decimals are different. They're not repeating themselves. Therefore, that will fall under irrational numbers. These are numbers that have infinite decimals, and those decimals may not be repeating. All right, they may not be recurring. And then we've got real numbers. What are real numbers? Real numbers are simply all the numbers that we have dealt with thus far. So it starts with your natural numbers, whole numbers, integers, rational numbers, as well as irrational numbers. All of them, we normally refer to them as real numbers. Okay, these are real numbers, and this is an example of your real numbers. The last set of numbers will be what we call non-real numbers. Now, non-real numbers are numbers that are not real. Okay, for instance, imaginary numbers like -4, -12, infinity, etc., etc. So those will be your non-real numbers, and numbers that are just not real. That's the basic principle. Now, here is simply abbreviation of what your number system will look like. You'll realize that non-real numbers is just outside, but it tells you that natural numbers are whole numbers are integers are rational numbers are real numbers. Okay, can real numbers be natural numbers? No, only if they give you an interval, and that interval also specified that the real numbers are simply a set of natural numbers. But natural numbers can be real numbers, but real numbers, not all real numbers can be natural numbers. Excuse me. That is why we can't say all real numbers are your natural numbers, but part of the real numbers will be natural numbers. Please note that outside your set of numbers, you also have irrational numbers. Okay, irrational numbers are simply part of your real numbers. It's simply your rational numbers plus your irrational numbers. Please note that your rational numbers covers excuse me, covers your integers, whole numbers, and natural numbers. And I gave you examples then. We're going to be converting decimals, especially finite decimals, as well as recurring decimals. Steps to follow, especially when we're dealing with finite decimals. Write the decimal in the numerator and divide by 1,000 if there are 3 decimals. Okay, if there are 2 decimals, you write the decimal in the numerator and you divide by 100. If there is only 2 decimals, or actually only 1 decimal, you write that decimal in the numerator and you divide by 10. Let's put that into practice. express this as a common fraction, please note that we've got three decimals there, which is 1, 2, and 5. So you'll write 1, 2, and 5 in the numerator. And now let's count how many decimals we have. It's 1, which is 1, the first decimal, 2, which is the second decimal, 5, which is the third decimal. So we have three decimals. So you're going to take that 125 and divide it by 1,000. Simplify it further. Now you know that 125 goes both into the numerator and denominator. Therefore, we divide both the numerator and the denominator by 125. 125 divided by 125 is 1, and 1,000 divided by 125 is 8. So that can be written as 1 over 8. Now let's express this one as a fraction, a common fraction. Please note that the only decimal that we are changing, simply we only changing the decimal to a fraction. So we'll keep 14 as it is, and that 6, we're going to divide it by 10 because it's only one recurring decimal. Now simplifying that 6 over 10, note that it will simply give you 3 over 5. So that is a mixed fraction. Now, negative 1, 2, how do we express it as a common fraction? We will take the 2 because there's only one decimal. Okay, we will simply divide it by 10. So the decimal 2, you just divide it by 10. You write 1 on the side as a whole, and that will give you 2 over 10. Now, please note that 2 goes into 10 5 times, so that can be written as negative 1 and 1 over 5. 3,04, we can simply write this as 3, and we take 4, we divide it by 100. Now 4 goes into both the numerator and denominator. In the numerator it goes into the numerator, it goes once, into the denominator it goes 25 times. Hundred, 75, you will write that as 175 over 100. 75 goes into 100 how many times? Actually doesn't, but 25 does go into the highest factor that goes into 25, and it's common between 25 and 100 is 25. I mean, that goes into 75. The highest common factor between 75 and 100 is 25. 25 goes into 75 3 times, and into 100 it goes 4 times. You can try these exercises in the ABC textbooks if you do have one. Now we're going to be converting recurring decimals, and I will give you this as an example, and we'll do it together. Converting recurring decimals. Remember, recurring means that the decimal is repeating itself. How do we convert the 0,2? First of all, you will need to expand that 0,2. Please note that 0,2 can be written as 0,22222. Then you can let it be equal to x. So x is simply equal to 0,22222. If there is only one recurring decimal, you will multiply both sides of the equation by 10. If there's only one recurring decimal, you multiply both sides of the equation by 10. So you will multiply the left-hand side by 10, and then multiply the right-hand side by 10. This is just to remove one of the recurring decimals to a whole number, basically to move it to the right just before the comma. So this will be 10x is equals to 2,2222. As I've said, since there's only one recurring decimal, you will multiply both sides by 10. Now, the first equation will be x is equal to 0,222. The second equation will be 10x is equals to 2,22222. Now, what you're going to do is that you're going to take the equation at the bottom minus the equation at the top. And you do it dealing with each side separately. You will start by saying 10 minus 1x is equals to 9. So that's what we're going to get on the left-hand side. We will get 9x. Remember, you keep the variable, you just subtract the decimals. So you take equation 2 minus equation 1. So 10x minus 1x will give you 9x. Do the same thing on the right-hand side. 2, 2, 2, 2, 2, 2, 2 minus 0, 2, 2, 2, 2, 2. That'll just give you 2. And then you just solve for x. To solve for x here, we'll just divide both sides by 9. So meaning that that's 0, 2, 2, 2, 2. If you were to write it as a common fraction, it will be 2 over 9. Let's see if that is true. And to make sure that I'm not teaching you nonsense, all right, let's see. You will simply take 2 divided by 9. Let's see if it gives us that. It does give us 9, 2 over 9, and then you just press S to D, all right? And let's see what we're gonna get. So that means our common fraction is correct. It is equals to 0, 2222. So 0, 222 as a fraction, it will be 9 over 2. Okay, it will simply be 9 over 2. Just to make sure that you guys understand it, I'll put it again into my calculator. We good? I hope we are. Let's move on. Based on what I've said, I need you to try this out. Remember, one recurring decimal, you multiply by 10. So if there's 2 recurring decimals, what are you going to multiply by? Follow the steps that we did above in the above example to do this one, okay? You will simply take that 3,12. Please note that we have 2 recurring decimals, so it will be 3,12121212. You equate it to x. Because we've got 121212 recurring, you are going to multiply both sides of the first equation by 100. Now you're going to take the second equation minus the first equation. So 100 minus 1x will give you 99x. 312,121212, you will minus 3,121212. That'll give you 309. I am sure that you all understand why I got the 312. All I did was just to take equation 1 and on both sides I multiplied by 100. 1x multiplied by 100 will give you 100x. 3,12121212 multiplied by 100 will give you 312,12121212. The next step, as I've said, you'll take equation 2 minus equation 1, which is 100x minus 1x. You start with the left-hand side. 100x minus 1x will give you 99x. 312, 12, 12, 12, 12 minus 3, 12, 12, 12, 12. That will give us 309. Then you divide both sides by 99. It gives us 309 divided by 99. Simplifying that will give us 103 divided by 33. Writing it as a mixed fraction, it will give you 3 and 4 over 33. Let's see if that is indeed correct. You will simply go to Shift, press this button, and then in the whole square, you will put 3. Numerator square, you will put 4. Denominator square, you will put 33. And press equal sign. You see it's the same as 103 over 33 divided by 33. Press this change button to a decimal. So meaning that our common fraction is indeed correct. Okay. All right. Now look at this one here. There's a little bit of a problem because one of our decimals is not recurring, which is 3. So the first step is to get rid of that 3 by taking it into a whole number just before the comma. Because it is just one position from being before the comma. You will remember this from, we did it under exponents. It falls under scientific notations, okay? So I'm simply going to move that 3 just to before the comma. And for me to move it to before the comma, because it's only one position, I'm only moving it once. I'm only moving it once. Therefore, you will multiply the original by 10. First of all, you will simply take the decimal fraction you're given, equated to x, move that 3 to before the comma. Because it's only one position, you only need to move it once to before the comma. You multiply both sides by 10. If I multiply x by 10, I will get 10x. If I multiply 22,3, 9999999 by 10, it will give you 223,99999, and that's it. All right, I've moved the 3. Now I'm only left with recurring decimal. Now I can follow the same principle that I have followed. So for me, to make sure that you don't get confused here, I'm going to take that original equation and just hide it. Now, how would you express if it was given to you this way? How would you express it as a common fraction? Since there's only one recurring decimal, I'm going to multiply that by 10. So I'm going to multiply both sides by 10. Please note that on the left-hand side I've got 10x. It means that that 10x will be multiplied by 10. On the right-hand side, I've got 223,9999. That means that 223,999999, etc., will be multiplied by 10. What is 10 times 10x? It's 100x. What is 223,999999 times 10? It is 2,239,99999. Now you're going to take equation 2 minus equation 1. Remember, that will be equation 1. Equation 2 minus equation 1. The equation that you multiplied will be equation 1. The equation that is the result of multiplication will be equation 2. Then you're going to take 100 minus 10. You keep the x, okay? 100 minus 10 will give you 90x. On the right-hand side, what are you going to get when you take 2,239,99999 minus 223,99999? You will get 2016. And then you divide 2016 by 90, simplify it, and that's what you will get. I think I can simplify that better. It will give me 22 over 5. Okay, let's see if that is true. Remember, if I punch that into my calculator, it should give me 22,3999999 because only 9 is recurring. Please note that that dot is only on top of the 9. It is not on top of the 3, meaning that the 3 is not recurring, as I have explained. All right. So I'm going to press shift, press this, shift, that, whole number box, I'll have 22. And then I'm going to have 2. I'm going to have 5 equal, change it. I don't know what's happening here. Let me just correct it. Let's try again. All right, this my calculator is just rounding it off, and it's not supposed to round it off. Okay, let me just prove it this way. I'm gonna have 9. Let's see if it will convert it into a common fraction. Press the equal sign. There you go. So it gives you that 112 over 5, which is the same as the 22 that I just gave you. Okay. I'm going to try again, but repeating the same thing will not give you a different answer. I'll fix this later on. All right. Try with your calculators. It will give you 22,3999999. Okay. Here's a transfer. Try that. I will simply give you 3 minutes. All right, your time is up. Let's do this one together. So how many decimals are recurring there? There's only one. So what's the first step? You equate it to x, you let it be x, expand it. To get the second equation, what do I do? Times both sides by 10 because there's only one recurring decimal, which is 6. That is 4,6666666. So there's only one recurring decimal, which is 6. That will give you 46,666 on the right-hand side. On the left-hand side, it will give you 10. Then you take the product, you minus the initial equation before you multiply. 10x minus 1x will give you 9x. 46,6666 minus 4,6666 will give you 42. Divide both sides by 9 in order to solve for x. You will get 42 over 9. And that is 14 over 3. You can write that as 4 and 2 divided by 3. Punch it into your calculator to check if it is correct. Remember, when you punch it into your calculator and change it to a decimal, it must give you 4,66666. To abbreviate it or to shorten it, we'll write that as 4,6 and put a dot on top of the 6. Try this one. All right, let's check. That can be expanded. It will be 2,1515151515. First, you take it and equate it to x and then expand it. Two recurring decimals, so you multiply that both sides by 100. 100 minus 1x will give you 99x. 215,1515 minus 2,1515, it will give you 213. Divide both sides by 99, and that's what you will get. Simplify it, you should get that. Put it into your calculator and change it into a decimal. It should give you 2,151515, which you normally abbreviate it or shorten it and write it as 2,15, and on top of the one you put a dot, and on top of the 5 you will also put a dot. In the mixed fraction, that's what you will get, which is pretty much the same thing as 71 over 33. Try this one out. All right. There's one non-recurring decimal, which is 0. I hope you noticed that. There's one non-recurring decimal, which is 0. So you need to move it just before the comma, which will just give you 0. And because there's only one non-recurring decimal, you will multiply those by 10. Just to move that non-recurring decimal. First, you equate it to x, and then move the non-recurring decimal by multiplying both sides by 10. Now you're going to ignore this one over here. It's refusing to, I'll just do this. Okay. Now the one that I'm left with, I have one recurring decimal, which is 2. Meaning that I'm going to multiply both sides by 10. 10 times 10 is 100x. On the right hand side, what is 10 times 0, 222? It is 2, 222. Then you will take the second equation minus the first equation. You will get 90x is equals to 2. Simplified, it will be 2 over 90, or simply 1 over 45. All right, if you have ABC book, please try exercise 7 in your ABC book. All right, I have more exercises for you. Try this one out. Please try this one again. Please stop. Let's check the solution. The times by 100 because there's two non-recurring decimals. Try this one out. Please know that you're going to take this and equate it to x. And then because there are three non-recurring decimals, you will multiply both sides by 1,000. Just like we have done, you're going to take equation 2 minus equation 1. A 1,000 minus 1 will give you 999. On the right-hand side, please note that you are taking negative 1,135, you're minusing negative 1. So when you minus a negative number, please remember it will be positive. So we've got negative 1,135, 555. You minus a negative 135. It gives you negative 1,134. Then you divide both sides by 999. That'll be equal to negative 1,134 divided by 999. Simplified, it will give you negative 42 over 37. As a mixed fraction, it will give you negative 5 over 37. Try this one out. Try this one. Please note here, there are two finite non-recurring decimals, which is 0 and 0. So you first start by multiplying by 100. And then because there's now one recurring decimal, you're going to multiply by 10. That will be it from me. Please check out the next video, which is lesson 2 of number systems. All I can say to you is,